We'll use the coordinate plane first to do some mapping of north-south, east-west distances. So what we're going to do then is we're going to locate the coordinates of the house. Well, the house is this position right here, and we need to start always at the origin when we do our counting. So there's our number line, there's our zero vertically and 0 horizontally. And we're going to go to the left. So we're going to go 1, 2, 3, 4, 5, 6 to the left. We always do our horizontal, our left and right, our x values first. So 1, 2, 3, 4, 5, 6, but it's 6 in the direction left. So we're going to say it's at -6 horizontally. That's always the first coordinate. So x, which is our left and right. Next, we need to know the vertical position. We can go up 1, so our vertical position is +1. And that's our y, which is our up, down. Okay, or our vertical positioning. So the man here is going to be at, right, that position there. That's in quadrant. This was quadrant 2. This is quadrant 4. So we're going to go 1, 2 to the right, 1, 2, 3 down. So we always write our horizontal positioning first. So it's 2 to the right, and it's going to be 3 down. Down means negative, so we write it as -3. And again, this is our x. That's our y. If we go to the coordinate -3, 2, and again, it's important that we have the order correct. We don't want to go 3 down. We want to go -3 is 3 to the left. 1, 2, 3 to the left. 2 up, 1, 2. So that's a +2, so we go up 2. And at that coordinate here, this is going to be -3, +2. And that's our soccer ball. And at 1, -6, again, the first coordinate is always our horizontal. It's 1, so we go to the right, +1. So we're going to end up right there, 1. And then from there we count down 6. -6 means down. 1, 2, 3, 4, 5, 6. We're at the car. So the car is at that coordinate of 1 to the right, 6 down. Again, the first coordinate is always left and right. The second coordinate is always up and down. So this is how we can use a coordinate system for mapping. However, we want to start using this coordinate system as to relate two different quantities. An x quantity, what we call the independent quantity, and the y quantity, the vertical, which we call the dependent. And we use these to make graphs. So we're going to be doing graphing. Graphing involves showing a relationship between two variables. So to read graphs, we need to understand what exactly are we relating to each other. So in this example here, we're relating along the horizontal, we're relating the time in seconds to the vertical, which is distance in meters. And we can see that as we travel here, we're kind of moving forward in time and forward in meters. And then it looks like we kind of slow down here. We kind of stop because it looks like there's no change in the distance. So it looks like we're stopped. And then we keep going, and it looks like we're going pretty fast there. So this picture kind of allows us to interpret some things about the graph. For one thing, it allows us to interpret something called speed or velocity. So some questions we can ask about this graph. So first of all, what quadrant is this graph? This quadrant is going to be quadrant 1 because we know that that's our origin. We're starting at 0x, 0y, or 0 seconds, 0 distance. So that means we're going to the right and up. That means we're in quadrant 1, which I'm going to just label as Q1. Why are the other 3 quadrants not shown? Well, in this problem, the negative time and negative distance is not relevant. negative time and negative distance are not relevant. Okay. When is a person moving the fastest? Okay, they're moving, looks like they're going to be moving the fastest where our change in distance, right? We went from 6 meters to 12 meters and we did it in a short amount of time. That means they're going fast. So that would be in part D, or section D. And that would be between, the time is 11 seconds and up to 13 seconds. And how fast are they going? Well, speed is a ratio of distance to time. And we can actually measure the distance and time because we know that we traveled 6 meters and it took 2 seconds to travel that distance. So how fast are they going? They're going at 6 meters for every 2 seconds. And we could write this as a unit rate as 3 meters per second. So this ratio is a rate, and this rate shows up as something that we're going to call later as slope. This triangle gives us the rise compared to the run, or something that we're going to call slope. And this slope is a ratio, and it relates to rates in problems. When is a person moving the slowest? Well, the person's moving the slowest where they're stopped right here, this section C, okay, or part C. And how fast are they going? Well, they've gone 0 distance. So how fast they're going, we'll do this as slope again, or ratio. We went 0 meters and over 3 seconds. Okay, so we went from 8 seconds to 11 seconds and they didn't move. And so how fast are they going? They are stopped or going 0 meters per second. So this is how we can analyze this graph, and this relationship is really important because this is how we want to be able to visually see relationships, and we can actually start finding parts of relationships that tell us something. For example, this piece here tells us the slope, which is also related to the speed or how fast they are moving relative to distance to time, or distance compared to time is what we call speed. And this relationship between distance and time can be visually seen in a graph like this. So we will end up using this coordinate system more to do relationships than to do mapping. But we're going to first start by making sure we understand how to map points on this coordinate system.